Khalid Al-Hadiri, section A05. That is the Thursday AM section. My student ID is right here. Oh, that's upside down. All right, my student ID is right here. And let's jump right into it. So starting off with question one. Question one asks us to find the identity, purity, as well as the concentration of our unknown compound in technique one. And so the first step is to find the identity of the compound, and the unknown that I was working with was unknown 1A-F21. And to find its identity, we have to look at its IR spectroscopy to start. Now, the IR spectroscopy gives us the exact functional groups that are within a compound. And looking at our specific spectrum, we could tell from this broad peak here that we have an OH group, and from these sharper peaks here that we have a hydrocarbon. Now, so think of the information that the IR spectroscopy gives us as a description for the compound. And so when we take that description and we apply it to the short list of compounds that maybe are unknown, the only viable options that meet this description are isopropanol and methanol. And so the way that we're going to know which one of the two is going to be our compound is to look at the boiling point. And so during my distillation, the compound that I had, its boiling point was fluctuating between 64 and 65 degrees Celsius. Now, the boiling point of methanol is 64.7 degrees Celsius. On the other hand, the boiling point of isopropanol is 81 to 83 degrees Celsius. And therefore, from the information we got from the IR spectroscopy and the physical property of boiling point, we can conclude that our unknown is in fact methanol. And so moving on to purity, for purity, we can't really give a quantitative value. However, we can give a qualitative one. And so the way we do that is by knowing that the more impure a compound is, the more that it will vary from its literature boiling point or melting point. And since, as we said, my experimental boiling point was 64 to 65 degrees Celsius, and the literature boiling point is 64.7 degrees Celsius, that means that our values are very close to each other. Now, we cannot conclude that our compound is 100% pure, but what we can say is that there is no concern for any impurities within our compound. And so finally, question one asks us to find the concentration. And so to do this, to find this, we're going to have to do a little math. So the first thing we need is the total volume of methanol collected after the distillation. So for me, this was 2.6 milliliters, and we're going to multiply this by the density of methanol. And by multiplying it by the density, the volume cancels out, and we're left with the mass of methanol. Now that we have the mass of methanol, we can divide that by the molar mass of methanol, giving us the moles of methanol. And now that we finally have the moles of methanol, we can plug it into our equation. Concentration is equal to moles divided by volume, with volume being the total volume before the distillation, which was 20 milliliters or 0.02 liters. And when we do this, we find that our concentration of methanol was in fact 3.2 molar. And so the sources that I referenced are right here. Question two asks us how our RF values would change if our eluent was changed to methanol. And so before we get into this, let's get familiar with some of the nomenclature. So the first thing we need to remember is what an origin is. And so the origin is going to be is just going to be the place on our TLC plate that's going to be spotted with our different solutions. So with my example on the right, it's going to be this black line down here. The second thing we need to know is what a solvent front is. And a solvent front is just going to be how far up the TLC plate the solvent or eluent travels. And so on my example here on the right again, that's just going to be this blue line up here. And finally, we need to know what an RF value is. An RF value is just going to be the distance traveled by the spot divided by the distance traveled by the solvent front. And that's going to be, of course, at the end of the experiment. And so again, on my example, it's going to be black line to blue dot, that distance there, divided by the distance from the black line to the blue line. And so how did our values look when we had an eluent of 1 part hexane, 3 parts ethyl acetate? Well, our solvent front traveled 3.9 centimeters. Our spot A traveled 2.7 centimeters, which puts out an RF value of 0.69. Spot B traveled 2.5 centimeters, which puts out an RF value of 0.64. And our co-spot was just a mix of both spots together, A and B, traveled right in the middle at 2.6 centimeters, which gives us an RF value of 0.67. So What change would we expect to see to these values if our eluent was changed to methanol? So before I get into that, I want you to consider this metaphor. So let's say I get a weight. Let's call it 50 kilograms, right? And I get three different people, and one who doesn't work out at all, one who works out every now and then, and someone who works out regularly. And so I tell these people to carry this weight as far as they can. Well, what would we expect to see? Obviously, the person who doesn't work out at all is going to carry it the shortest distance. The person who works out intermediately is going to carry it further, and the person who works out regularly is going to carry it the furthest. So essentially by strength. And so you may be thinking, what does this have to do with TLC? Well, what I'm getting at is the spots on our TLC plate are going to be the weight. You gotta think of the spots as the weight. And so the different people are going to be the different solvents. And you're probably thinking, well, what distinguished our different people was their strength. What's going to distinguish our different solvents? And that's going to be the polarity. So the more polar a solvent is, or an eluent is, the higher it's going to carry the spots on the TLC plate. You may be thinking, why? Well, the more polar a solvent is, the more favorable interactions it has, and the more easily it dissolves the spots on the TLC plate. Therefore, we say those spots prefer the mobile phase as opposed to the stationary phase, meaning that they're more willing to move up the TLC plate. And so, since methanol is much more polar than 1 part hexane, 3 parts ethyl acetate, we will expect to see all three of our RF values to go up, since the spots are going up, meaning the numerator is going up, while the denominator is staying constant, which is our solvent form. Therefore, RF value for A, B, as well as the co-spot will be expected to go up if methanol is in fact used as an eluent.